Today I'll show you the demonstration of R installation and also the RStudio installation. So we'll use in the class, right, RStudio as a graphical user interface. Why? Because this have a simple layout. So first of all, I'll show you how to download and install R, and then I'll show you the installation of RStudio. So first of all, if you want to utilize RStudio, right, if you want to write code in RStudio, you must have R in your system. Otherwise, you cannot use RStudio. So this is important. So first of all, the people generally follow the step where they install RStudio first, and they R first, and then RStudio after that. So, or you can do other way around, but you must have R in your system, and then only you can use the RStudio as a graphical user interface. Okay. So first of all, where you can download the R. So you just have to use here CRAN in the Google search, and it'll just provide this first page, the comprehensive R archive network. Yeah, so you just have to open that. Yeah, and here on the first page, download and install R. Okay, so you just have to follow this step. And here we have it R for different operating systems. Right now I'm using a Windows machine, so I can just use the third one. Maybe based on your window or based on your operating system, you can choose the first, second, and third option. So I'll just go here to third, and I'll download the base distribution. So here, the install R for the first time. I'll just use this one, and then here we have a download R 4.4.1 for Windows. Yeah, it will take few seconds because this is not a very big file. Just have 81 MB, right? And yeah, so let me do the installation. The installation step is very simple. You just have to select next. I'll show you in between. There are some informations. Choose yes. Yeah, I can choose English as a language, and here. So this is very important. So you'll have here the general public licensing and other information. So GNU public licensing version 2 June 1991, right? And here we have a copyright and other, so the Free Software Foundation, INC. And if you go further down, these are very basic information about the general public licensing. Yeah, you can read, but these are not required. Okay, I can do next here. This is a default path, right? It will basically stored in C drive under the program file. I'll not change. Then I'll just use all the default installation. So main files, 64-bit files, and messages and translations, right? So I'll choose all three. And then here I'll just use as a default. I'll not customize. You can do that, but I recommend just use a default one. The next, again here next. Yeah, I don't want to create a quick launch shortcut. Okay, this is complete. So let me open this. This is the R 4.4.1. Yeah, I can open, and this is the window layout. Okay, so this is first window console, right? Here we generally write the code. For example, I can create a name as, okay, let me just use character as create online training. And for running the script in R, this is R, right? You have to use control plus R button, right? Not enter. So you'll have to use control and R. uh, here we have, and if we just want to showcase or print, you'll have to use this one. So here uh, we have to use this way. So you just have to put enter. So this is console, right? Here we have various information. This is a version of R. Then we can extract the license, we can extract the citation, demo. If you want to know about some basic features, you can use demo or help, right? And it will basically guide line by line. Okay, and here, for example, I can create a vector of maybe name. I can just write few names here. So we have, okay, so let me just write a few names. Read Lakshmi, then yeah, then picture. So just stop so that I don't have to scroll to the right. Okay, so here I just wrote various names. Suppose I want to run this. So what I have to do? I just have to I have to press enter. Yeah, it basically this sends this cursor, right? If you notice, this is a symbol. It sends to the next line. That means this is complete, right? And there is no error. Suppose I want to print. So how we can do that? I can just write name and then again enter. So it will basically print all the names one by one. So this is the way. So if you want to just utilize this console, so the problem here is you'll have code along with the output, right? So this is not clean as such. So what we do, we prefer a different way of writing the codes, and here this is a script. So what I can do, I can write the code here and I can run, and it will basically execute while sending a particular line of code to a console, right? It will execute and it will basically showcase here the result. So here I write the code and it will basically send the that code like a line of code, right, in console for execution purposes. So in that case, we'll have a very neat code. So what this means, so let me show you. So let me copy from here so that I don't have to type again. So I can just write, and for running the script here in the R editor, this is called editor, R editor, and we generally use R editor for the coding purposes, right? So to run the code here, I'll have to use Control plus R button. Okay, so for example, I want to run this whole thing, and this is the character vector. So what I can do, I can just press a cursor anywhere, right, in this line, and I can use Control and R. So it will basically sense that line here in console for the execution purposes. Okay, then suppose I want to print. So what I can do, I can just write here CHAR and again Control R. So it will print this the text that is present inside this character vector CHAR. Okay, so this is called auto printing because here we are not using any explicit function, right? So this is called auto printing. Okay, we can write an explicit function. So we can write print CHAR and it will do the same thing. So this print is a function that is present in R. It will basically print a particular objects. Okay, so this is the thing. Similarly, we can do for the name. I can just copy all the names. Control and R. And for example, I want to print, so I can just use name. Yeah, and here we have. And this is case sensitive. Suppose I just write here, so it will give error because we don't have object with the name where we have capital M. So I just specify the variable, right, or object name as lowercase name. Okay, so that's why I'm not able to recognize that. So this is case sensitive, so be careful while extracting a particular objects. Okay, so this will fails as we don't have object with, yeah, this. This is case sensitive. Okay, so next part is we can create again a vector of age or maybe some numeric, because this is a character vector. So I can create a vector of numeric, and for that we can very easily extract the we can very easily again print, and then we can extract the element. So first of all, I'll show you how to extract the element from the name vector, right? So any question, anybody so far?
Yes, sir.
Yeah.
So, sir, with double quotation only we can work, or with single quotation?
We can use single quotation as well, right? Let me add here one name. Maybe I can just write here. Yeah, so it works with a single quotation.
So is there any restriction with quotation? Because like in SAS, in macros, we have to use double quotation.
No.
So is there any restriction?
No, here it will not have any restriction as such, right? But if we create here with a single quotation, by default in the output label, it shows a double quotation.
Double quotation. Okay.
Correct. Yeah.
Okay. Thank you.
So let me run this. Oh, sorry. Control R. Yeah. And if I run this name, I'll have here, you can notice the last name I specified, I assigned with a single quotation, but it is showing here with a double quotation. Okay.
Yeah, got it. Yeah, thank you.
Perfect. So then the next is how we can extract some names, right? For example, this is a name, and here if you notice there is a symbol. We have symbol 1, that means this Rashid is at the first position. Then again 8 here for the Ranjit, so we have this 8. This 8 means this is at the 8th position. So we can count and we can very easily verify. So this is 1, then Lakshmi 2, 3, 4, 5, 6, 7, and 8. So that means all the objects that we create in R, it basically stored as a vector format. Okay, vector are nothing but a combination of same kinds of element together. Okay, so if we combine same kinds of element together, I'll basically forming a vector. So you can have an element in character data, you can have element in numeric data, you can have complex data, you can have logical data, right, where we have true and false. So we just have here 4 categories of data. I'll cover that part in the next class. So this is the way. The next part is how to extract. For example, I want to extract this name Akshay from this list. So what I can do, I can use nomenclature. Okay, so I want to extract Akshay from this name. So here I just have to count, right, the position of Akshay in this list. So here this is first, then second is Lakshmi, third is this Sanjan, then Leela, then here we have 5th position, right? So I can just write so what I can do, I can just write a vector name. I'm just writing a general formula, right? And then here in the big bracket, you'll have to write index of the name that you want to extract, right? Or placeholder. Okay, so this is a generic formula. And for commenting any line, you just have to put this symbol, right, hash symbol at the very beginning. Okay, so here I can just write, so vector name is what, name. So I can just write name. I want to extract the name Akshay, so Akshay is at 5th position, so I just have to write 5 here, and then I can close the bracket and then Control R, so it will extract. Similarly, we can extract Leela, we can Ramya, anything. So for example, I want to extract Ramya, so Ramya is at 6th position, so I can just write 6. Similarly, anything. So suppose I want to extract from Rashid to Gitanjali, right? So Rashid is as 1st position, and Gitanjali is as 7th position. So what I can do, I can just write and I can extract. Okay, so let me write this way. Okay, so here I'll show you how to extract multiple names together. So I'll have to use this name, and then inside this big bracket I'll have to specify the number. Okay, so you can use this way. Here 1, 2, 3, 4, 5, 6, 7, right? And here we have a lot of names, so I have to combine these. Yeah, sorry, this does not work here, so I'll have to combine all the number or index. And here, whenever we have more than one number or more than one element that you are specifying, you'll have to use combine operator C. And what this combine operator does, it will basically combine all the elements together. Okay, and this is the way. This is not a efficient way. I'll show you the efficient way in a minute. So this is the way how we can extract. Okay, so instead of just writing this number one by one, what I can do, we can use some function. So in R, we have a colon function. This function basically create a integer sequence. Yeah, so what this means, so for example, if I write 1 colon 5, so it will basically create a sequence starting from 1 and it'll end at 5 by an increment of 1. Okay, so I'll utilize this. So here, if you notice, 1 to 5. So because we need to run the sequence start till 7, so what I can do, I can just extend this to 7. Okay, here we have, and now I'll use this 1 colon 7 here instead of this whole number, right? Yeah, so I can use name, then big bracket 1 colon 7, and that's all. So it will do the same thing. Similarly, there are other features also for this colon function. Suppose I want to create a decreasing sequence. So decreasing sequence is the sequence where we have a decrement, right, from one in the consecutive element, right? For example, I want to create a sequence starting from 7 to -2. So what I can do, I can specify the first element as 7 and the last element as -2. So it will basically create a decreasing sequence for us. Okay, it starts at 7, and by a decrement of 1, right? If you notice, we have a jump of -1, right? And it ended here at -2. Okay, so you can create increasing sequence, you can create decreasing sequence, but here the problem is you just only have to have either a jump of 1 or a jump of -1, or a difference of 1 or a difference of -1. You cannot have other difference. So for that, we have another function that is called seq, sequence, and we can create here. So we have to specify here the start position, end position, and then by. So if you don't want, if you don't know the functions, right? For example, I don't know the sequence function, how we have to use. So you can use seq, and before that you can use question mark, and then you can use Control R. So what this does, it will basically open a help page, and here we have, it will give the information. So this seq is a function that is a part of base R. Okay, then here we have description about this function. Yeah, so this will generate regular sequence. Okay, then here we have a function, so we'll have to use seq, then from is nothing but the starting position, to is nothing but the end position, and then by is basically a jump. Okay, so let me create that. seq, I'll start from 1, right? So let me just write explicit. So I can write from is equal to 1, comma 2 is equal to 7, and I'll use by is equal to 1. Yeah, so it will basically create the same thing. So you can use either this 1:7 or sequence function, and you can very well create a sequence and you can place. So if we use this one, right, this is an efficient way. Okay, but anyhow, this also works and there is no issue. Okay, so I'll pause here. Any question, anybody so far? Let me write this combine operator. This is called combine operator.
Hey, Rajit.
Yeah, please.
In the name vector, there is a very limited data, right? So we are specifying 1 to 7, 7
Correct.
to minus 2.
Correct.
But what if we have a huge data? How can we get from the vector?
Yeah. So what you can do, you can extract the length of that same thing. For example, I don't know how many names we have right in the name. So what I can do, I can use a function. Let me show that length of name. So it will basically extract the number of element that basically this vector, this name vector stores, right? And now I can use a sequence function, so or maybe colon function. So I can use 1 colon length of name, right? And it'll create a sequence starting from 1 to 8, and you can basically extract whatever the number that you want to extract. Is that okay now?
Okay, thank you.
And anyhow, because this is just a kind of demo, right? I'll give you a various example with the real data, right, in the part 2, because we generally don't have this 7 data point, right? We'll have a data point in 1,000, right? So anyhow, this is not a very efficient function. These are not efficient functions. These are basically just a start, right?
Yeah, Ranjit, this is Riaz.
Please.
Yeah, Ranjit, like, can you just brief me for like what, because I just joined a bit late.
Okay.
So what had happened, like what?
I just showed here. First of all, I showed the installation of R, right? And here we have console, right? So we generally, here we have console, then we have editor window. We generally prefer writing codes in editor so that we can have just a code here, right? And you can run with Control R. If you're using editor, you'll have to press Control R for running a particular line of code, right? If you're using console, so here the problem is you'll not have a neat and clean code. You'll have code chunk and also the output, right? So this is not clean, so that's why we prefer writing code in editor, right? But if you so the execution happens only in console, right? So if you run the code chunk with Control R, it will basically sense here in the console for the execution purposes, and then it will show if we have error in particular line chunk, so it will basically throw an error. So for example, here where it is, okay, there was one example where I used capital. Yeah, so here for example, this is the error. So error object name not found. Why? Because I use a prop case name. Okay, and I define the name in lowercase. So this is case sensitive, that's why it's not able to recognize that, and it throws an error. So this is the thing. And here yeah, I showed other example. For example, I want to create a vector. So what I can do, give me a second. For example, I want to create here a vector. Yeah, so here I created a vector of name. So for example, if you want to combine multiple things together, so you have to use combine operator C. Okay, and this will help in combining the element, right? The next part is here.
It's like a concatenation function, right?
Yeah.
Okay.
So concatenation is basically working at the text level. Here we are combining the element, right? It seems that this is similar to a concatenate function, but this is a slightly difference here. In R we have cat, that is exactly the same as concatenate function. We have paste 0, that is same as concatenate. For example, what is the difference here? So the combine is basically, C is combine operator. This is not concatenating, this is basically combining the element together. For example, I'll show you the example of cat function. For example, here we have Riaz and then clinical student. Okay, so I'm just concatenating these two. So if I run this with control R, what this does, it will basically combine this text. Okay, it is basically combining, collapsing this text together. But here it is not doing that. It is basically combining the element, right? It is not doing concatenation. Okay, so hope you are able to understand the difference. Yeah,
I got it.
Yeah, similarly we have another function paste. So that does work in the same way. So let me add here. So it will again combine or concatenate. So this is the thing. Okay, so this is the way how this works, and then I just showed here how to extract the elements. So for extraction, you just have to specify the object name or vector name. Then in the big bracket, you'll have to use index. So because I'll show you the extraction in detail, maybe tomorrow and day after, maybe in the next class. Okay, and this is just some claims. So if you're a vector, you'll have to use single big bracket, and inside that you'll have to specify the placeholder or index name. Okay, then here's sequence creation and all. Now what I'll do, I'll show you the class of a particular objects. So class is basically a data type. So for example, I want to extract the class of this vector name. Okay, so what I can do, I can just write here class with a small c, and here I'll have to specify the name. So if I run this, it will basically showcase a result as character. That means this is a character element. Okay, so what this class does, data type or class of an object. So object is basically this one, name is an object or variable name. Okay, and yeah, so I already showed how to extract the multiple elements together. Yeah, so with this way, right? Or you can use concatenation, combine operator C. Okay, the next part is I can create. I just showed various example with a character element. I'll show you with the name, with the numeric element. So for example, I can create a vector of age, and here I'll create different values of age. So for example, 25, 28, 29, 31, 23, 37, 36. We have here total 3, 6, 7, and one more 8. Yeah, so here we have, and I can print this object age, and I can also extract the length, or I can count as well. So we can use function. Here we have 8. Then the next part is, suppose I want to extract the 37. 37 is at 6th position. So what I have to do, I just have to write age, big bracket, and 6. So it will extract 37. Yeah. Then suppose I want to extract 37, 36, and 38, last 3 elements. So what I can do, I can just specify the number. So whenever we have to specify more than once, we'll have to use combine operator C. So 6, 7, and 8. Yeah, you can use this way, or you can run the sequence. This is up to us. Okay, so let me run a sequence here for extracting the same thing. I can use here 6 colon 8. Yeah, so these are the way how we can extract. Suppose I create one more variable for height. So I can use 168, 172, 171, any number. This is just an example. 3, 3, 6, 7, and one more, 174. Yeah, here we have, and now I can extract the object, right? So we have these many elements under the height. Suppose I want to also store some NAs. So what I can do, I don't have the values for this last subjects, right? So I can use NA here and will store as a numeric NA. So if I print this, you notice this is NA. This NA means, so we don't have the values, and that's why I specify NA. Okay, so this is the way. Then similarly, I can create a column for weight, vector for weight. I can use any number, 66, 67, 68, 72, 74, 71, 6, then 75, 72. Yeah, so we have also the column of weight, and here we have. Okay, so let me extract the length of this weight and height. So GTH. Okay, similarly I can use length of weight, and this is also 8. Okay, you can also check the class of these two variable. Numeric, because I specify as a number, right? And then you can also check the class of weight. This should also be a numeric. Okay, so this is the thing. So here I specify, I created a vector of name, I created a vector of age here, right? Then vector of height and weight. And if you notice, these are an individual element, individual vector. So vector of name is of character data type, vector of age, height, and weight. These three are of numeric data type. Okay, similarly we can have a character as well. For example, I can create a gender variable, a sex variable, and I can specify here male and female. So that will be again a character data, right? So I just have to check, so that's why I'm skipping. Okay, so next thing is how we can combine these 4 vectors together so that we have a rectangular data. Okay, so for that we'll have to use another structure that is called a data frame. So we can create a data frame using data.frame function, and here we'll have to specify the object that you want to combine. So I want to combine a name first, then age, then height, then weight, and so on. So if I run this with Control R, here we have age, height, weight, right? So this is the way how we can use, and this is nothing but the rectangular representation of data. But there is one catch. So this will basically
Rajni, one quick question.
Yeah. Please.
So like by creating vectors, like it's nothing but the columns, like variables in our like SAS, right?
Correct. So these are, maybe you can think of an individual column. Correct.
Okay, individual columns, and by using the data frame, we are creating one data structure by combining all the vectors.
Exactly.
Okay.
So data frame is a nomenclature in R, but this is same as our data sets, right? It can have further properties, right? So in case of data frame, if you are creating a data frame, all the columns or variable must have an equal number of element. Okay, so if you don't have a particular element, so in that case you'll have to store either numeric NA or character NA, right? Based on the data type of a particular column. For example, we don't know the name. For example, I don't know this here. I don't have the name for this last element. So what I can do, I can go and I can store as a character NA. So here I can either use quotation. Oh, sorry, here I can either use this blank, right? This is again same thing, and I can run. Okay, if you notice, this is blank. Or you can use NA underscore character underscore. So these are the two way of storing character missing. Yeah, so you'll have to use NA underscore, sorry, NA with capital N capital A underscore character. These are a small letter underscore. This is basically a kind of keyword that is specified in R for storing a character missing data. All right. So let me show you. Yeah, if you notice, we have it's explicit, and this is basically, if you notice the symbol that is at the beginning and at the end of NA, that indicates that this is a character data. And also this name, other elements are characters, that's why it should be character. Whereas here this is a numeric missing values. So we'll have to have an equal number of elements, and it must have okay. So that is the main part. Benefit of creating data frame is, if you have a data frame, you can do data processing, right? Structuring, right? From unstructured data to structured one easily. So that is the benefit. Yeah, so data processing is easy in case of data frame. Data frame objects, right? So that is the benefit. So and also, as a default, if we import any files from external drive, by default R creates a data frame for us, right? Why? Because this is efficient. Okay, so they just design this code in such a way so that you create basically a data frame. Okay, you can extract the maybe number of rows, number of columns of a data frame using dim function, right? You can use dim, and here I have not specified any name, so you can specify that. Maybe I can use data underscore df. Df is a short notation for data frame, right? So this is the way I can just run this, and I can just print that df, data underscore df, and here we have. So now we have name, and I can check the dimension, the number of rows and number of columns that particular data frame. Yeah, so here if you notice, it is giving two number, one is 8, the other is 4. So the first number corresponds to the number of rows. This is row number 1, 2, so on to row number 8, and 4 is basically because here we have 4 variables: age, name, then height and weight. Okay, so it will basically give 2 number. So let me just write a comment. Okay, so this is the way. Similarly, we have another function, one more function, that is called str. What this function does, it will basically extract the structure of the data, right? For example, I'll use here data underscore df, so it will basically extract the structure. And if you notice, this is giving similar kinds of result as if you want to relate with the SAS, when you use proc content, this is similar to that. Okay, so it will first provide the data dot frame, because data dot frame is the structure. Here we have 8 observations and 4 variables. And here if you notice, I just wrote here row number. Row number is nothing but the observation number. And the first variable and 4 variables. First variable is character, right? Here we have few elements, name. Then second variable is age. This is numeric. Here we have few values. Then third variable is height, again num, few values. Then fourth is weight, again num, and here we have few values. So these are the thing. So what this str function does,
and extract the dataset information.
Correct. Structure of the. So we call object because it can be vector, it can be anything, right? So for example, instead of data underscore df, I can use str of name. Yeah, this is not a data frame, this is an individual vector. So that's why in a very in general term we use object. Object can be vector, it can be data frame, it can be function, anything. Okay, so this is the way. The next is we can also extract the element from the data frame, right? So I'll show you. For example, I want to extract the column of name from here. So what I have to do, I have to use first data frame name, then dollar symbol, and then the variable that I need, right? So I can use name, and here we have the names. Okay, I cannot use directly name. I also have to specify the this data frame name. So the generic rule is we'll have to specify data frame name, right, first, and then we'll have to specify dollar symbol, and then the element, the vector, or the variable. So this is the formula. Yeah, so if you notice, I just use first a data frame name. Data frame name is nothing but this data underscore df, and the variable name is name. Suppose I want to extract the column of height. So column of height is here. So what I can do, I can use the same structure, data frame name underscore df, right, dollar symbol, and then I can use height. And here we have, yeah, you can notice these are the same values. Yeah, 168, 172, and at the very end we have any. Okay, so this is the way how we can extract. There are other way also. We can use a big bracket. For example, I can use data underscore df big bracket, and I can, for example, I want to extract the second column. Second column is age, so I can use here comma. So this first position is for row. Let me just write a generic code. So this is for row placeholder, and the second position is for column. Yeah, so this is the way. And here we should have a data frame name. Okay, so let me comment this line, and now I'll use here. So data underscore df dollar symbol, and I not dollar symbol, I'll have to use big bracket. And then suppose I want to extract the second column, so I'll have to use 2. Yeah, second column corresponds to age, so I want to extract the column of age, and here we have, right? So what this is doing, it is basically extracting all the elements from that column of age. Suppose I want to extract only few elements. For example, I want to extract first, second, and third of our first, third, and fifth. So what I can do, I can specify the position 1, 3, 5 here at the first place, right? Because I'm just restricting, right, the element based on the number of observation. So if I run this, now it is basically extracting the first, this is 25, then third 29, and fifth is 33. right? So you can put this restriction, right? If you don't specify anything at the row space, it will extract all the elements, right? If we don't specify anything in the column, it will extract all the columns. For example, I want to extract I want to extract this third row. So what I can do, I can just write here data underscore df big bracket and 3, and I'm not specifying anything at the column place. So what this does, it will basically extract all the columns, right, and only the row number 3. So you can notice row number 3 is for Tansin, right, and 29, 171, and 68. Similarly, we can use another number, data underscore df 1, and here, so we'll extract the first one. This is Rashid at 25, 168, and 66. So if you are not specifying anything at the column place, it will basically extract all the columns, right? If you're not specifying anything at the row place, it will extract all the rows. Okay, so this is the way we can control or extract, right? This is a very simple structure. If you want to drop a particular column, so how we can do that? So let me show you. So here, let me add that comment, right? Because this is important. So it will extract. So it will extract a second column. Column 2, right? Here we are extracting to extract row number 1, 3, 5 of variable of column 2 Yeah, then here we are extracting just row 3, and here we are extracting row 1. Yeah, so these are the way how we can access. So let me show you how to drop a particular column. So data underscore df big bracket. Suppose I want to drop a particular column, so I'll just skip the row position. I can skip, right? And then in the column position, suppose I want to drop the column of weight, so I can just use minus symbol and the position for the column of weight. So column of weight is at the 4th position, right? This is the 4th position. Yeah, or you can just print that. Let me just print first. Control R. So if you notice, column of weight is at the 4th position. Name is first, second is age, third is height, and then 4th is for weight. And I'll use here 4. So if you use minus symbol, right? So minus symbol to remove particular column. Okay, so let me run. Here if you notice, we don't have the column of weight. It basically dropped that. Okay, suppose I want to drop 2 columns together. So what I do, you can use a combine operator. Yeah, for example, I don't need the column 3 and column 4, so I can use 3, 4, and before that I'll have to use a minus symbol, and that's all. So it will drop these 2 columns, column 3 and column 4. Okay, so any question, anybody so far?
Ranjit, like the data will be stored in column wise or like a row, or like how it will be stored in the memory?
Correct. So it basically store as so here we have 2 structure. One is row is for observation, and column is for variable. For example, here if you notice, this is a row number 1, then 2, 3. So these are the basically information about the single subjects. Maybe you can think of this is a patient 1 having age, this one height, weight, right? but here we have a column. So we have a similar structure. So we have columns on the top, right, and row on the row as observation.
Yeah.
Okay.
Yes. So can we give the name, data frame name for that particular where it will be stored? Like in SAS, like it will be stored in the workspace, right?
Yeah.
Work library.
Yeah.
So,
By default, it stores in a global environment, right? If you want to know how many objects that you created so far, so we have a function ls. So that is the downside of using code in R. You cannot see, right? You cannot see all the objects. I'll show you the installation of RStudio, and you can very easily see how many objects that you created so far, right? So if I use ls function, it will basically extract all the objects that we created so far, and including the objects that I created from the previous RStudio session. Yeah. So if you notice, yesterday I created a variable pkg, right, for the package installation. Okay, so that's why we have here and the other objects. And I created this age, char, date underscore df, height, name, num, right, today. Okay, so we have how many objects? We have total 12 objects. This is 11, right, and here this is 12. So this ls is very useful function. All objects from the global environment. Okay, so these are the things. So the downside of using writing code in R, it will not give auto suggestion for the variable name. It will not give auto suggestion for the function name, and also we don't have dedicated windows for the element, so that we can see how many elements we have created so far, right? So the problem here is you can overwrite, because if you're writing a very big line of code, you can overwrite on objects, because we cannot have a dedicated window where you can see how many objects and what are the objects name that we created so far. So this is the problem. And also there is one more problem. So for example, if I create the plot, let me create a plot for a very basic height as x and y as weight. Yeah, so if I run this, it will basically create a plot in a dedicated plot window, but you'll not have plot window always, right? So that is also a downside. You cannot see how many plots you have created so far. So because of that, we move to RStudio, a graphical interface. Why? Because that provides a better programming experience. Okay, so let me show you how to install. So for installation of RStudio, you just have to use maybe I can just type in do a Google search, download. Yeah, I'll give here the first page. This is Posit. Earlier we usually call RStudio, but now they changed the name of the company, right? Now we have Posit, and here I can just use the first link. Yeah, I can accept. I already installed the R, so it is giving here the process. So first we'll have to install R, and then you can install RStudio. So I have a Windows machine, so I can download R for desktop, right, for Windows, or I can go here and I can choose based on operating system. Okay, so right now I'm using Windows, so I can use either this one or the first URL here. This is slightly big software, right? I guess 200 something MB, but it will not take much time. And I'll show you the installation, and then I'll also give you an idea about the different windows, right, and how to write the code here. So there are other graphical interface. For example, we have called TinR. Not Tinder. This is the layout. This is TinR. Okay, and this is the layout of this graphical user interface for R. And why people not use? Because here, if you notice, there are a whole lot of options, right? So this layout is not clean, right? People also prefer this one, but based on their preferences, right? I prefer this RStudio. Why? Because that have a simple and a very nice layout. Okay. So that is the one thing. So let me just install. We also have other graphical user interface, rattle, then R commander, right, and all. So, but I will use RStudio here. So let me write here so that you can remember. So the graphical user interface, these are the basically a way of writing a efficient code, and here we'll have various. So RStudio. Then the second one is maybe you can think of a TinR. Then fourth is third is a rattle. Rattle is basically for data mining, right? So if you want to do a data mining kinds of thing in R, so you can use rattle. Then we also have R commander. This is again for data extraction as and so we'll use RStudio because this is the having a very simple layout, right, and user friendly interface. Okay, so here let me go to the installation. Okay, so this is again just next. I don't want to use any kinds of shortcut, right? I'll use as a default installation. It'll take relatively more time as compared to the R. So let me give you a idea about the window. Yeah, so let me use this one. Yeah, so in RStudio, we have these 4 windows. Basically, I'll show you once again once I install that, right? So let me just yeah. So first is a source, right? This is where we write the code, right? This is, you can think of this as an editor, right? We'll write the code here. We'll write the code here, and then we'll run with the run button or control enter button. So here we'll have to use control enter, and then it will send that code to console for execution purposes, right? So the code is evaluated in the console, right? If you have error, it will basically throw an error. Otherwise, it will create that object and will send that object name here in the environment. Okay, then we have files and plot. If you create any plots, it will basically sense here in the plot. Then also we have list of packages where you can install very easily. And then also we have help window where you can ask for any help if you are not able to recall any function name. So console is a place where execution happen. Here we just write the code. You can think this as an editor. Yeah, environment, and then again we have a history. For example, if we for example, you are using multiple RStudio session and you are running various codes together. Sometimes we may lost the code, right? Suppose you just close the window without saving, but you can also extract all the code from this history window, right? So it will basically track a history of all the code chunk that you ran in the previous RStudio session. So you can go and you can extract. So sometimes this is useful, right? Just to track, right, what you have run yesterday or day before yesterday. Okay. So these are the things I'll show you once it completes. So yes, the installation is complete now. Okay, so let me open RStudio. here this is the symbol. I'll have to select here the Unicode. Yeah, so I'll just use 64-bit version of R. And that's all. So it will take few seconds. And now I'll create a new window. Okay, so here if you notice, by default, this is my source. This is console. Right here we have terminal. We can run the code using this one. This is similar to command prompt, right? And here if you want to give any background job, right, if you want to assign some work, right, it will basically execute here. So we'll not do that part very often, right? And here we have environment. So if you create anything, it will basically sense here in the environment. Then history, connection, tutorials, and this is files where we can provide the working directory location as a default. Plot, if you create any plots, it will basically sense here. Then packages, help, viewer, presentation, right? So help is basically a window where we can ask help. For example, I want to know more about str function. I can just use str and enter. It basically showcases the functionality. Okay, so now it is extracting the str function from, yeah, so let me use other, maybe I can use okay, let me use str. It is basically maybe I can use sequence seq. Yeah, so you can notice this is for sequence generation. This is exactly the same, right? How it extracted, right? When I use question mark, okay, in RStudio. So here in R. So for example, I showed some places. Okay, yeah, here. So this is the way of asking for a help, right? So help window, or you can use help function with the function name. Yeah, this is again explicit way of asking for help. Okay, it will provide, it will extract the material. Yeah, so this is the way you can just use either question mark or help function. Similarly, if you are using RStudio, you don't have to use question mark. You can just type and you can press enter. It will showcase all this thing. Or here also the same thing works, question mark or help function. Okay, the first thing is whenever you are writing a code in RStudio, you'll have to follow certain steps. So first of all, you'll have to set the working directory. First, you'll have to close. You'll have to clean all this stuff from here. Okay, so let me type here. So step first. So we'll have to clean our environment, right? So right now here in the global environment, this is called our environment. This is similar to working directory, right? If you want to relate, so here we have 3 data sets and 4 vectors. So what I want to do, I want to clean all. So we have a function. We can use rm function. Rm is a function just to remove a particular element. Objects. So for example, I want to remove this ADLSL1, right? So what I can do, I can use rm, then ADSL1. And if I run this with control enter, so here for running the script in RStudio, right? Code in, sorry. We'll have to use control plus enter. Yeah, so I can run this and will basically remove that object ADSL. You can do 2 things together. For example, I can just write here ADLB. Oh, sorry. Okay, let me just do this way. Okay, I guess ADSL1 is not, that's why it is giving error. So this is the way you can just write 2 and you can clean. But whenever we have different kinds of elements, right? So this ADSL1 and ADLB, these two are data sets. That means the data type is same for these two elements. So that's why it can remove very easily. But if we have a multiple type of data type, for example, sometimes we have a data, sometimes we have a vector, function and all. So what we can do, we can now use here a combination of functions. So I'll use first ls function. I hope you can recall, if you use ls function, it will extract all the elements that is present right as of now in our studio session, right? So these are the objects we have, right? Where this character num1 pkg, these are the vector, this ADSL is data. So there is a difference in data type. So what I can do, I can assign this whole thing to a list, and list is a very beautiful objects in R. So it can basically holds all type of data type together. Okay, so I'm storing this whole thing in the list, and then on top of that, what I'll do, I'll just use rm function just to clean the global environment. Yeah, if you notice, everything is removed from this global rm environment. This is the function we generally use at the first place. Okay, the next step is to set the working directory.
Ranjit, could you please tell about list?
Yeah, I'll show you. I'll describe list in much more detail and as we proceed, maybe in upcoming classes. List is an object in R that can hold a multiple type of data type together. So it can hold a numeric vector, it can hold a data frame, it can hold function, it can hold logical, complex, any type of data you can store in the list. So that's why I use list, because here, if you notice, ADSL was a data frame and these four are an indivisible vector. Okay, so we have a vector and we have a data frame. There is a difference, right? So that's why you can store these right elements in the list and you can clean all in one go. Hope this makes sense. I'll give you a different description about the list in the upcoming classes.
Sure.
Okay. So the second part is second step is just to set the working directory, and for that I already covered in the demonstration class. You'll have to use set wd. Set means we are setting the working directory locations. That means we are providing our some location where it can store all the objects as a default, and it can very easily import, right, or pull the object that is specified or that is present at this working directory location. So there are two benefits. It can store all the objects at that location, and it also imports the object easily that are present at the working directory location. Okay, so these are the advantages. So for example, let me store the working directories location here. So let me first show you the working directory. So by default, it basically so this is for setting of working directory. Yeah, I'll show you first working directory location. So for extraction, you'll have to use get. Get means it will basically extract the working directory location, and by default, it will basically point out the location in the C drive, right? If you notice, this is the default C drive, user, HP, OneDrive, and documents, right? In your case also, it will basically points in a C drive. Okay, suppose I want to store at some other location where we have a dedicated folder. So what I can do, I can use set wd function, and inside this parentheses, I can specify the single quotation, double quotation, and I can specify the path where I want to set. Okay, so let me do that. I want to set at this location, so I can just paste. But here, R does not recognize the single backward slash, so I'll have to make this double. Yeah, and then it will work. And if I use now get wd, so now it will point at this position. Okay, so this is the way of okay, so it will basically extract. There is another way you can use a single forward slash. This is okay, or you can go here in this session and you can do a working directory set, right? But this is, I don't recommend this way because you'll have to go everywhere in the session and then select that. That is not efficient. Just specify a line of code and you can specify the path. Okay, the next thing is what we can do, so whatever the element that is present at this position, right? For example, if you have some Excel file, you can import without specifying the file path. That is the advantage of setting the working directory. And if I close this RStudio session, by default it basically store at this at that position, okay, at that location. Okay, so these are the two advantages. And also sometimes we want to optimize the space. So right now in the system, the laptop that I'm right now using, we just have C drive, right? But if we have a other drive also, so right now there is an issue with this laptop, we just have C drive. If we have other drives, I prefer setting up working directory in some other location other than C, because I don't want to occupy the space of a C drive, right? Because this is related to all the software and all, everything is still installed here in C drive, so I don't want to compromise this space and all. Okay, but there is no other drive because of some issue, so that's why I'm just setting here. Okay, similarly we can run all the code chunk that I showed here in the RStudio. So let me go and copy paste. Yeah, you can use the same structure, there is no difference. The benefit here is in RStudio you can see the objects, right? For example, I can create the name. So if you notice, we have the name where we have 8 element. This is character data type, and here we also have few names. Okay, so this is the advantages, and you can very easily print that, right? The same nomenclature. Then I can again create the other one. For example, age and race. Age. Let me copy all starting from. I am copying pasting because this is similar structure, right? I don't have to very much. So this is age, you can extract the length, same thing works, right? If you notice, it has better layout, better experience. Here we have the objects that we have created so far. Here we have a console, right? You can also, for example, I can create a plot. X is equal to, it will give auto suggestion. For example, I write here plot, so it will give auto suggestion for the functions. I can press the tab button, then it will give functions, right? The keyword for X, right? So we have to specify X. So X, I can use height. I can use Y is equal to weight. It will give also the auto suggestion for the variable name, right? So this is the benefit. And here we can create the plot, and it'll stay here in the plot window. Okay, you can create plot. This is a base way of plotting the thing, right? You can use ggplot too. I will cover that part in later session. Okay, so these are the advantages. The other thing is here the help. We can just write the help, and you don't have to search, right? But here also the same function works with the question mark. You can use mean. It will basically open the help window for mean, or you can use this way. Mean, just open the same thing, or you can use help function and then mean, same. So you can use this all 3 methods for help, right? And then so, and here we have objects. You can get an idea about the history. So if you notice in the earlier session and the previous class, I showed this demo, this creation of RSS, and then we have here all the removal I showed. Yeah, here I just remove these objects, then list, right? ls, and it will basically track all the code chunk that I ran here in RStudio session. Okay, if you lost these codes, right, that we have in editor, you can very easily go in this history and you can copy paste, right, and you can retrieve. It'll have the list, right? Very big list. You can go before as well. Okay, so this is the benefit of history. Connection is basically just to establish the connection with the external world, right? And tutorial here we have maybe you can read a few packages. For example, you can just click here learner R and basically install that package, and we'll have a very simple layout that helps in learning R. So you can use that resource for the learning purposes, right? If you have some extra time. Otherwise we will cover these all in the class. Okay, it will take time because it will basically install various packages. Okay, so I'll pause here. Any question?
Hi, Ranjit. So I have a question. So when we run the code chunk, usually in SAS, we see as a data set that we open like SAS viewer.
Mm-hmm.
So
here also we can create, for example, let me create a vector, that's data frame, data.frame, and I can combine the vector of name, age, height, weight, and I can keep a name. Maybe I can use df. So here we have, and if you notice, this is the layout. Okay, suppose you have a very big data. Let me import a data. Let me extract the data from this formatter R package. So formatters are, this is the sorry. Okay, I'll have to install that, I guess. So it will take a few seconds and install. The installation is done. Now I load, right, and let me showcase the data. For example, I need ex_adsl. So here we have the adsl. Okay, I can store into another name, and I'll have here. So if you notice right now 400 observation 31 variable, I just have to click here and it will basically open here in the editor. Now you can scroll to the left and right for checking the variable. Here we have option, you can apply the filter. For example, I want to select only the maybe a specific, maybe I can use subject ID. I can select ID hyphen of 28. So it will extract 28, right? So it also extract the one where we have a 1 2 right at the end. But so this is the thing. We can go and I can apply the filter. Similarly, if you want to select a particular country, you can use that. So this is the way we can have that option. You can very easily use this filter or maybe sorting option, right? For example, if I click on the particular variable, basically sort in ascending, right, at first, and if I click again, it will basically sort in descending order. Okay, so this is the way. And similarly, you can apply the filter. Maybe, for example, if you want to extract treatment arm A, so these are the subjects having treatment arm A. So we have that similar kind of layout. Okay,
thank you.
Perfect. So because there might be the case that there are other functions that you are thinking about, right? So we'll cover these one by one as we proceed, right? This is just our I guess 4th class. So we'll cover. So I recommend just spend half an hour right after the class, right, and just practice. Just run this code chunk, try to modify here and there, right, and see what is going on. And feel free to ask question. I'm here just to help, right? So don't hesitate. And you also have a WhatsApp group, so you can drop me a question if you have any burning question, right, while practicing. Okay, I know all of you are working, maybe, so it's really hard to extract some time, right? So, but please.
Ranjit, this is Riyad.
Please.
Actually, I tried to install like the packages format S. But I'm getting warning like R tool is required to build R package, but not currently installed.
So what you can do, you can uninstall R and RStudio right from your system, and you can do that installation once again. It will not give an error. Sometimes while installation, there may be some issues, right? And because of that, it'll get an error of R tools, right? But that is, you can just uninstall both the software, R and RStudio, and then you can do installation once again. Not a problem. Okay.
I'll try that after.
Perfect.
I was able to install the RStudio.
Perfect. Yeah.
But the layout is different from yours. I only have
Okay, yeah, that's a very good question. Yeah, so layout, you can just why I kept this layout, right? Because for me, I have if I stretch, right, if I just minimize that part, I have a whole lot of area for writing the code, and here I can see the code in the console, right? So you can go here in the view section, right? Here we have pans, and you can shift. You can shift console to the right, left, right. You can just use this structuring. Okay.
Okay, got
Yeah.
it. Good.
So I recommend try to keep this layout, because this is give a better experience. If you have a bigger screen, you can write code here, and you can see the right. You can run and then see all the result here in the console. Okay, so that will provide more space.
So how?
Yeah,
one question.
Sure.
So how do we know what packages are default when we the RStudio initially, and then
so here we have a function search. I guess yesterday I covered that. So it will basically list down the package that is installed, right? I just installed this package and loaded this package, except this. These all are a default one. Okay, so here we have package this RStudio because we are using RStudio. Then this one, GR devices, method, datasets, graphics, stats, utils, right? Base and autoloads. Autoloads is not a package; it's basically environment. So these are the packages that is pre-installed. Okay.
Okay, thank you. Yeah, sorry, sorry, I didn't attend.
No, it's okay. It's okay. No, it's not. Not a problem. Yeah. Anybody can miss.
Hi Ranjit, even I'm facing the same issue. Like it's an error in install of package. Could not find function install dot package. Do I need to restart again?
What error you are getting? R tools.
Could not find function install dot package.
Okay, maybe you can just try that. You can install everything and then install once again. Okay. Mm-hmm. Not have issues. Okay. Yeah. Okay, so any last minute question, thoughts, anything? We have 5 more minutes.
Ranjit, like question here, like whatever the like in the edit window you have typed with you taught like will you be saving this code?
Yeah. I'll save all this code chunk, right? What I wrote here in RStudio and also R, and I'll provide as a material, right? So that you can
because we can do revise whenever we will get
correct. Yeah, we are providing that. We will provide all the materials. Don't worry. We also provide. Sometimes we'll use some additional data sets, right? So I also already created a folder, right? Maybe you can check. Let me show you. Okay, so this is September batch. So right now we have 3 classes. I don't know why this is giving. So here datasets used during the session. So I'll use these datasets as we proceed. Then here we have all the material related to project. We'll cover these in part 2 of the course. Okay. Then in the learning, if you go here in cheat sheet and books, so here we have a cheat sheet for a string R. Cheat sheet is basically 1 or 2 page document where it basically lists down all the functions. And we have these books, so you can just refer. I'll just show you how to download, right? And if you can download from here, or maybe I can show you how to download, and right, maybe in upcoming session. Okay. Yeah. Okay, so any last minute question, thoughts, anything before we sum up?
Yeah, what is the basic packages that we need to download?
Yeah, so we'll cover that part one by one, right? This is the thing, because I don't have right now list, right? But we'll cover each and every package that is required for the clinical art demonstration. Okay.
Okay.
Yeah, so I'll not have to worry about that part. Yeah, you just have to yeah.
So a few classes I missed, and I thought like CST hours, and I was joining 1 hour late. So. So these are like bits and pieces you are covering, or a few of the basics were already covered?
No. This is we are now at class number 4, right? The first class is demonstration. Second and third class is related to our programmer role, and third was history and development, right, of R. And this is the fourth class where I showed the installation of R. So this is you're basically not missed anything, right? So you can start. Yeah, and we have the recording. You can just revisit the recording.
Okay.
Yeah.
Okay. Thank you.
Okay, then if you don't have any questions, we can sum up the class. So thank you, everyone. Thank you for your time. Bye. Nice day.
Thanks, Ranjit.
Yeah, and one thing. Sorry. One thing. We'll meet on. We'll meet on
Monday.
Yeah. So that is one part.
Okay.
Yeah.
Thank you.
Thank you, everyone. Have a nice rest of the day. Bye.
Thank you, bye.
Thank you.